So if I have a shape, like a rectangle, okay, and I want to find, and I have a circle, and I want to find the area around the outside of that circle, how would I do it? So let's say this is 4 by 3, and I have a diameter in here of 0.5. Let's make them units of centimetres. Okay, they're all centimetres. So if I was to ask you to find the shaded area from back in grade 8, what would you do? Right, you'd find the area of the rectangle, you'd find the area of the circle, and you'd find the difference. Yeah? Literally that simple. Right, it'd be the area of the rectangle minus the area of the circle gives you the total. Now, funnily enough, when it comes to finding the integral area between curves, it's exactly the same process. Right, so if you want to find the area between those two curves on the screen, right, so if you integrate, so you'll notice here that we've got two functions, f of x and g of x. There can be any functions you like, okay? In this particular case, f of x is greater than g of x. In other words, it appears higher in the graph. So if you graph them, f of x is above g of x, okay? And you want to find the area that's shaded, right? Then basically, it's exactly the same idea, all right? If you can find the area under f of x, which is all the way down to the x-axis, right? And then you find the area under g of x, which for that one is all the way down to the x-axis, then the area between them is literally the difference between the two, okay? Now, the beauty about this process is you can do it two ways, right? You can actually find the area separately, the two areas separately, and subtract, or you can find the difference between the functions and then find the integral of that function, and you get the same outcome. Is that okay? So it's a really simple concept, and we already have all the skills. So finding this is not difficult. And this is probably the area. This is probably the section that integrals are used most, is to find areas between things. Okay? It's unlikely you ever want to go down the axis, but you want to find areas between functions. Okay? So let's have a look at a simple example. So what I'd like you to do with this is I'd like you to graph the two functions. Okay? So we're going to do this tech-free, ladies and gentlemen. We're going to do this tech-free. So I'd like you to graph those two functions on the same set of axes. Why do I always do it with a highlighter? Okay. So you're graphing y equals x squared and y equals 2x. So we're going to do it tech-free to start with. We will learn how to do it on our calculators a little bit later, as in graphing them. Oh, bell's going to go. That's a very bad parabola, but you get the idea. I'll do a better job. Hang on. Bit better. Okay, so there's y equals x squared. By now that should be a given. You can draw that. Here's y equals 2x. I'm going to do this with a really exaggerated, whoa. Okay, so there's y equals 2x. Okay, and we want to find the area in between. So we're looking for this area in there. So in order to find that area, what information do we need? points of intersection. Okay, so our first task is to find the points of intersection. Okay, how do we do that? Without a calculator. Come on. These are our equations. Someone other than Will. Here's my two equations. I want to find the points of intersection, ladies and gentlemen. So one of you other 5 people, how do I do that? Just go ahead and do it. Do you know how to do it?
Not really.
Oh, okay.
You just substitute 2 points.
No,
I mean,
no.
the lines equal each other.
That's right. If points of intersection are points that occur on the same, but that occur on both equations, right? So therefore, if it's a y value in the first equation, it's the same in the second equation, same with the x, right? So therefore, at points of intersection, the y's are the same and the x's are the same, yes? So therefore, the y's are the same, make the equations equal each other. So it's points where x squared equals 2x. That's how you find points of intersection. You let the equations equal each other, yes, and then you do that. All right, so then you go, well, I can't solve that, but I can solve that. What is that? Quadratic. How do I solve quadratics without a calculator? Factorise. All right, I can use the quadratic formula, yes, absolutely. C is 0 in this case, right? But it's a lot quicker to factorise. What's my common factor here? X. Right, you don't have to use all the tricky stuff because there is no C value. So this is a very simple factorising. So there are my two, that's my factors. I better rub out my area down here now because I don't need that anymore. Come on, hurry up. Right, so how do I then find my values for X? Null factor law. Oops, wish I could spell. Null factor law, okay? So therefore x equals 0 or x minus 2 equals 0 or x equals 2. So they're my points of intersection, ladies and gentlemen. So if I scroll back up and have a look, does that look like they're reasonable, 0 and 2? Yeah, okay. So we've got 0 and we've got 2. Right? So in this case, we are going to integrate between 0 and 2. Is that okay? So we can do them separately. So we can integrate separately. We can integrate the x squared between 0 and 2. We can integrate the 2x between 0 and 2 and then subtract those answers. Or alternatively, we could subtract them first and then integrate. It saves a little bit of time usually to do it that way. Now, which is my top function? 2x. How do I know it's my top function? It's an obvious question. It's literally above it. In the area that we're interested in, the blue line is above the green, red. What colour is the parabola? Orange, right? So the blue line is above the orange line. So therefore, it's the function we write down first. It's literally that simple, right? So it's going to be 2x minus x squared dx. Now, if you had done it the other way around, what do you reckon your answer would have been? Negative. And is that okay? Yep. You just take the absolute value because you just want to know the area. So it doesn't matter if you do it backwards, right? It just means you're going to get a negative answer. And I don't want you to freak out if you see a negative answer and go, oh my God, what have I done wrong? Right? It doesn't matter. You just go, oh, okay, well, I've just got the functions around the wrong way. No big deal. My answer is this. It's okay. It's not, but try it. It comes out to be negative. Okay, so if we do this, but it's easier, obviously, if you can do it in the right way around, because it just saves time later. So that's what we aim to do. So if we're going to integrate 2x, we get x squared. We're going to integrate x squared, we get x cubed on 3 between 0 and 2. This is an easy integral because the 0 bits are just going to drop off. It's going to be 2 squared minus 8 on 3, so I might just do it that way, so it's 4 minus 0 minus 0. So 4 minus 8 thirds, so 8 thirds is what? 2 and 2 thirds, so that's 1 and a third, which means it's 4 on 3. And that's it. I think for all of you, the trickiest part of that was finding the points of intersection. It's a bit of a worry, but that's okay. We reminded you how to do that now. Okay, so as long as both equations equal y, make the equations equal each other, rearrange and solve. Okay? So, if I was to do that on my graphics calculator, how might I do it? So fortunately, here's one I prepared earlier. Okay, different functions, but the instructions are there. So we're going to look at that on Friday. Okay, what I would like you to do is have a go at some questions. If I just find this one, there's another question over here, right? Which is the example on the question before. Okay, this time I'd like you to have a go at that question, right? Which is on the same page, so it's on the area between curves page. It's just over to the right. Okay. It's the area enclosed by x cubed and x. So again, you have to find the points of intersection. All right, what are they? And then integrate appropriately. And I will see you 3 on Friday, and I'll see you 3 in 10 seconds.